For the last 2 months, I was put in a random team of four to work on our first game project. This happened to be our midterm project. We were told to use Unity to develop a game of our choice. This was a tough challenge, as none of us had any prior experience to using this game engine or even developing a game with a team. But after completing this project, we all gained a lot of experience. I would like to share with you an overview of things I learned and implemented throughout this project.
The first thing I had to implement was the player combat system, which includes weapons, throwables like flashbang, and weapon switching. Here's a simple showcase. This gun can be shot, reloaded, and aimed. You can also shoot while it is aimed. Player can also switch to a different weapon. You can also equip a flashbang, throw it, or even hold it, and release it whenever you wish to do so. Every weapon, whether it be melee or an instant projectile weapon, has a bunch of parameters that can be tweaked to add or take away certain functionalities. For example, you can tweak a weapon to allow player to hold or tap the attack key. This can be used to allow automatic rifles to be fired at a certain rate while player holds down the attack key, or for a pistol, allow player to tap fire to shoot bullets. Each weapon type has at least one different parameter that can be tweaked that other weapon types might not have. For example, a knife needs a hit range, so only the knife has that parameter. As I started the implementation process of the player combat system, I ran into an obstacle, which was I wanted the player to be able to have different types of weapons in his inventory and be able to switch between them. And I really didn't know exactly how to implement it. So I started to abstract all functionalities each weapon type had in common and made a script off of it which became the base weapon class. Since this way, I can implement all other types of weapons with inheritance. Then I created child classes that inherited from the base weapon class. Here, the base gun class, which is used for all gun type weapons, extends the base weapon class and adds functionality a gun will need or have. For example, muzzle flash, bullet, and aiming or reloading functionality, those are all functionality a gun should have, and only a gun should have. We can even go further into the base weapon hierarchy, or weapons hierarchy, and see that the base shotgun extends from base gun and has functionality a shotgun might have that's different from a regular gun. The next thing I implemented was an object pooling system. Creating or destroying bullets or bullet impact particle systems at runtime and destroying them could affect performance. So, I made a simple object pooling system that works with any object that is defined as a poolable object. Before I show you the internals, let's see an example. Here is a simple example. When I shoot, the bullet spawns in, then when the bullet collides with anything, it doesn't get destroyed. Rather, it's disabled. As we can see in the hierarchy, when it's gray it means the object is disabled, and when I shoot again, it uses the same bullet that was used last time, which we can look into the hierarchy and see that it's white, meaning it's active. So, a poolable object is an object that can be pulled either automatically or by the client. This object gets disabled rather than destroyed after its usage has been completed. After creating an object that can be pulled, the pullable object, I created an object pool. An object pool has a list of pullable objects which the client can use at any given time. Also, one edge case I ran into is that when all objects in pool are being used, I had to add another instance of the object to the pool, or else there would be no instances left in the pool for the client to use. With the object pooling system being implemented, I ran into another issue where there were multiple object pools for the same object being created. For instance, if you had two guns that use the same bullet, then there will be two bullet object pools rather than one, which was a problem I had to solve. So to resolve it, I created a manager called Object Pool Manager that kept track of all object pools in the game. I did so by creating a dictionary of a string as the key, which is the object pool's name, and the object pool as its value. So the client now has to use this manager to create any object pool, and internally, if an object pool already exists, then no new object pool will be created. Rather, the existing one will be used. I also created other managers such as Bullet Impact Manager that manages all the particle systems that will be spawned in when bullet collides with an object. For example, when bullet collides with door, it should spawn in some sparks, but when it collides with rock, it should play another particle system. Another thing I worked on was the loading and transition screens. I got started by implementing a basic screen management system. Here, we can see the screen manager. Its job is to keep track of all the screens in the current scene. Screens are kept in a dictionary and cannot be accessed directly by the client, but can be shown or hidden by a screen name. All screens need to extend the base screen script for the screen manager to know about the screen. Base screen defines a screen name that can be used to show or hide the screen, and some methods that child classes can override. A usage of the screen management system is the XP screen or the leaderboard screen, which are both implemented using the screen management system and by me. Altogether, this project was an amazing learning experience, as I learned a lot from the last 2 months. From working together as a team, learning source control with Git, creating certain gameplay mechanics, Unity just in general, and learning and executing the agile game development process. I can't wait to learn more about game development.